Anyway, there's a good PowerPoint slide for this in Chapter 5. So an example of a good index fossil is a particular trilobite referred to as paradoxides. So trilobites lived all throughout the Paleozoic from 541 million to 251 million years. What is that, 300 million years? But there were all kinds of different species that came and went. And some stuck around for longer periods, some stuck around for shorter periods. This particular trilobite that doesn't look like any other trilobites was not on the planet for that long. So it's a great index fossil. Now, an example of a bad index fossil would be a brachiopod. That's the Lingula species. So I believe that's the only brachiopod we have still living. Maybe there's a couple other types. There were all kinds of neat brachiopods, say back in the Paleozoic, that many species of those that have gone extinct. But this particular brachiopod, we could consider it to be a living fossil, as in it's been around for hundreds of millions of years. It lived from the Ordovician back in the Paleozoic to today. You can go to the beaches of North Carolina and dig in the sand and find Lingula brachiopods. So this is not good for an index fossil because the age span that it has is just huge. And actually we can refer to the Lingula brachiopod as a living fossil. All right, our last set of notes for this chapter. Maybe I can have a seat again. I think so. Oops, we've got to scoot back. All right, so in green, this is our ending stuff for this chapter. And this is a really neat topic here. How to try and get an absolute age date, radiometric date for sedimentary rocks. Can it be done? Not so much. Okay. So if you had a sandstone and you were a brand new grad student and you didn't really know yet how things work and you had all kinds of grant money so you could send all kinds of things for radiometric dating, you might want to know how old the sandstone is. And you might take a quartz sand grain from that sandstone and send it away and pay to get a radiometric age date from it. And you'd be wasting your money, okay? Because that age date is going to tell you when that little piece of quartz first grew out of a magma into that granite, okay? And that's going to be way, way older than your sandstone. So radiometric age dating that quartz is not giving you the age of the sandstone. Now, something else I mentioned in an earlier PowerPoint, either in Chapter 4 or in Chapter 6, glauconite, which is a green mineral. Glauconite has radioactive materials in it. So glauconite, if it's present, glauconite is sometimes present in marine sands and or muds. Now, there's no guarantee that every marine sand or mud you look at is going to have glauconite. But if it's there, that's wonderful, because you can send away a sample of that glauconite from that marine sand or mud, and it's worth your grant money to pay to have that age date run. It gives you an age of deposition for the sandstone. But you don't always find it. And of course, if it's a terrestrial sandstone, well, you're not going to have any glauconite. Okay, so what can you do? These last two bullets here. So what you hope for is that you have nearby igneous and or metamorphic rocks that might be adjacent to the sedimentary rock you're looking at, or maybe these igneous and or metamorphic rocks cut through the sedimentary rock, and then you take samples of the igneous or metamorphic rock that's nearby, and you get an age date on that, and that might help you to narrow down or estimate the age of the sedimentary rock. So last bullet here, basically it takes indirect methods, okay? So you hope that in the sequence of sedimentary rocks you're studying that you have interbedded lava flows from the past or interbedded volcanic ash flows from the past. If you have that here and there within your sedimentary rock sequence, you can take those samples, send them away for radiometric dating, and that can help you to kind of narrow down the age date of sedimentary rocks. So again, this is actually a really interesting and cool chapter. And when we get to it, right now, as I'm filming this, we're still trying to finish Chapter 2 in class. Okay, so when we do get to Chapter 5, I do hope to take some time to look at some images on the PowerPoint slides. That's about it. I think we're at 24 minutes, so hopefully that won't take all day to upload onto YouTube. All right, have a great afternoon.